Welcome to the video lecture series of operating system. In today's session, we are continuing with the topic Introduction to Operating System. Myself, Kunal Panchal, your instructor. In this particular session, we are going to discuss multiprocessing operating system. So in the series of evolution of operating system, we have started with batch processing operating system. Then we have understood the spooling. Then we have discussed multi-programming operating system. Then in the recent session we have discussed multitasking or time sharing operating system. And now we are going to discuss multiprocessing operating system. But before going to discuss multiprocessing operating system, let us take brief review regarding the previous operating system that we understood. So in the multi-programming or multitasking operating system, we are dealing with one single processor. So as I told you earlier, by having single processor machine, we cannot achieve real concurrency. That thing you need to keep in your mind. Okay, I repeat once again, by having uniprocessor or a single processor machine, we cannot achieve real concurrency. If you want to achieve real concurrency, you need to have more than one CPU or you can say processors in a single machine. Then and then we can achieve real concurrency. So in the case of multiprocessing operating system, we can achieve real concurrency, because in multiprocessing operating system, that type of system consists of more than one CPU. Okay, so how we can deal with multi-processing operating system, how it works, what are the pros and cons of such type of operating system. Let us discuss these things in detail. Okay, so how multi-processing system works and what it means actually. So in simple terms, if a single system or a single computer system have multiple CPUs, in that case we can say that it is nothing but multiprocessing system, because in which we can execute more than one process or we can say task simultaneously, so that at the end we will have higher throughput as compared to other operating system that we have discussed so far. So you can see in this particular figure we have CPU 1, 2 up to n, and these different CPUs are associated with one single computer system. So except number of CPUs or we say processor, the remaining other hardware and software resources would be same in the case of computer system as far as this operating system is concerned. Okay, so like number of registers, memory, okay, IO devices, all these things would be same. Okay, only one change we have in our computer system, which consists of more than one CPU as per our requirement. So these many CPUs are shared with one common memory, or we can say one common main memory. But in this case, if you are increasing number of CPUs, definitely the main memory requirement would be higher, because you know very well CPU can directly deal with main memory only. Means if you want to execute any process or program, that program resides into a main memory, and once it resides in main memory, then and then CPU can execute that process or as a program. Yes. So if we have more than one CPUs and if you want to get benefit from it, definitely you need to have large size of your main memory so that we can adjust more and more number of your processes or you can say programs in it for concurrent execution. Okay, for real concurrency. Okay, so 2 or more CPU in a single system, that I already told you. In close communication, sharing the system bus, memory and other IO devices. So in the case of multiprocessing system, all the other resources like system bus, memory, IO devices will be shared among different processors we have. Okay. Now, in the case of multiprocessing operating system, different process may run on different CPU. So, in which we are getting true parallelism. So, there is only one way through which we can achieve real parallelism when you have number of CPUs within a single computer system, or you can say when you have more than one CPU in a single computer system. So then and then you can achieve real parallelism or as a real concurrency. Okay. Now, if you want to design such type of system, there are 2 ways through which you can design. Okay, one is symmetric way and second one is asymmetric way. So let us discuss what is symmetric way of architecture or way of design. So in the case of symmetric way of design, one OS, as far as operating system is concerned, again we have a single operating system which control all the CPUs that we have in our machine. So one operating system control all the CPUs and each CPU has equal rights in the case of symmetric way of design or you can say architecture. So multiprocessing system can be organized into 2 ways. One is symmetric and another one is asymmetric. In the case of symmetric, in which all the processors will have equal privileges or you can say equal rights. Okay, means all the processors can access the system bus, all the processors can access the IO devices, all the processors can access the memory, okay, for reading and writing purpose. All these things would be same for each processor in the case of symmetric way of design. Now the next way of design is asymmetric way, in which there is one architecture called master-slave architecture you can implement, in which one CPU will work as a master and remaining CPUs would be work as a slave. So system task on one processor and application programs on the other CPUs, and one CPU will handle all interrupt or IO devices, and they are easy to design but it is less efficient. Means when we are talking about asymmetric way of architecture, so it can be implemented with the help of master-slave concept, in which one master node we have, or we can say master node means what? One processor we have finalized, and that processor will be worked as a master, and that processor will associated with the interrupts and IO devices. Means what? IO oriented operations, hardware interrupt oriented operations will be handled by that processor only. The remaining processors we have, they are dedicated for computation, because the main objective of multiprocessing system is what? To increase the throughput of a system. Means more and more number of user processes we need to execute, okay, at the same moment of time. That is the main objective of multiprocessing system. Then and then we can increase the throughput of a system. Yes. So only one processor would be dedicated to handle the IO oriented or hardware oriented interrupts activity, and the remaining processors would be handle user oriented task. Okay, so in this way you can implement the asymmetric way of architecture. In this case, they are easy to design, but it is less efficient. Why it is less efficient? Okay, that we will see in the later slide. Okay. Now, once we have the multiprocessing architecture or system, now what are the advantages when we are dealing with multiprocessing system? So, in multiprocessing operating system, definitely the throughput would be increased. What throughput means? Throughput is nothing but number of process executed per unit time. So definitely in this case we have number of CPUs which are dedicated for user-oriented tasks, and one CPU, specifically if you are talking about asymmetric architecture, in which one CPU is dedicated for hardware interrupts and IO devices, and the remaining CPUs would be dedicated for user-oriented tasks. So definitely, when we have more than one processors, the number of process executed per unit time would be more. So definitely, throughput would be increased in this case. Second advantage is what? Increased reliability. So in this case, why we can say that reliability is increased? So in this case, reliability in terms of failure. How? Suppose we have say for example 5 processors, and out of 5, one processor is dedicated for system oriented activities. Okay, and it is dedicated for IO operations only, and remaining 4 CPUs which are dedicated for user oriented tasks. So out of these 4 processors, if say for example 2 processors are failed because of any reason, okay, still we can manage our task by having the remaining 2 processors as far as user activity is concerned, as far as user processes are concerned. Yes, so definitely the performance would be slightly degraded, but your task will not be stopped in this case. So in that context, we can achieve increased reliability in terms of failure. If something going wrong with one CPU, we can do the same task with the help of the other available CPUs. Okay, so we can increase the reliability when we are dealing with multiprocessing system. Third advantage is cost saving. Cost saving means in this case what will happen? Suppose in the case of multiprocessing architecture, how we can reduce the cost. So suppose instead of having number of systems with a single CPU, what we have in this case, we have a single machine, single computer system which contains number of CPUs. So definitely with that respect, definitely it is cost saving approach, because instead of having 5 different machines with 5 different dedicated CPUs, definitely we are not doing sharing phenomenon in that case. Okay, so definitely it is a costlier approach, but in this case, except CPUs, all the other resources would be shared. Yes, so that in that context it is cost saving. Okay, next, battery efficient. Nowadays, the load is increasing day by day as far as computer system is concerned. So user requirement is increasing day by day. So definitely in what in this case, how we can say that it is battery efficient? Suppose if we have 4 CPU, but 4 CPU will not simultaneously run. Definitely, if you have 4 processes, 4 CPUs would be run simultaneously. But if we have 4 processors and out of 4 processors, we have only one process for execution. So at that time, only one processor will be in execution mode. The remaining 3 processors would be in idle mode. In that case, the battery life of that system would not be used. Yes, so means the increasing battery life we can achieve when we're talking about multi-processing operating system, because it is advantageous to have, say for example, in real life application, suppose if I have one building and instead of putting one big generator, I'm going to have 4 small generators. So what will happen if my requirement is less at a particular moment of time? Only one generator or 2 generators are sufficient to accommodate my requirement. So definitely the consumption of the power would be less. Okay, so in that context, it is battery efficient. True parallel processing, that we have already discussed in the previous slide. By having multi-processors within a single system, we can achieve true parallel processing, or you can say true concurrency, or you can say real concurrency. What are the disadvantages of this type of system? Definitely, it is more complex to design because the multiple processors are associated with the same machine. So we need, as I told you, large size of memory and arrangement or in implementation purpose. It is somewhat difficult to design. Okay. Next, large main memory, that is already discussed by me in the previous slide. Because we have multiple processors, so to execute multiple processes on multiple processors, definitely that set of processes we should have in main memory. And if you want to accommodate that many processes, we need to have large size of memory. Okay, so that is one disadvantage. And the last one is overhead, or we can say coupling reduced throughput. So what will happen in this case? As I told you, processors are increasing, but number of system bus, number of registers, number of IO devices are same. It is not increasing. Yes. So what will happen? It means what that resources are shared among various processors we have. So suppose if at a particular moment of time, if 2 processors require the system bus to access certain information, or you can say at the same moment of time, 2 processors require the print-oriented service at the same moment of time. So definitely in this case, coupling is what? Dependency. So dependency will be there. Why? Because processors are multiple in terms of count. But what about other resources? Other resources are same. They are using in shared manner. So dependency would be there. If 2 processors requesting to access the same resource, okay, at the same amount of time, and so definitely the printer cannot be accessed by two processors at the same amount of time. So definitely dependency would be there. So at a time only one processor can access the printer, because printer is non-shareable resource. Even though it can accept more than one request, but at the same amount of time it can process only one request only. So definitely the throughput would be slightly reduced. Means suppose you cannot say, suppose if we have 4 processors, so you can increase the throughput by 4 times. No, not like that. It will increase the throughput 3 times, you can say that, 3 times, or you can say more than 3 times, but not exactly 4 times, you cannot say that. Yes, because The other resources are using in a shared manner. Okay, so these are the pros and cons of multi-processing operating system. So definitely in today's environment, we are using such type of operating system through which we are getting higher throughput, higher reliability. It is cost-effective approach. True parallelism we are getting with the help of this scenario. Yes. So this is all about multi-processing operating system. I hope it was clear to you. Thanks for watching this video. See you in the next one.